Good morning, students. In the last video, we had studied basic radical analysis steps and the radicals present in different groups. Today, we will study the systematic analysis of groups in basic radical analysis. So, we know there are basic radicals are divided into 6 different groups, and these are labeled as Roman letters. This group 1, group 2, group 3A, group 3B, group 4th, group 5th, and group 6th. All basic radicals, they are divided into these 6 groups. So, first, for the systematic analysis of basic radical, the simple way to analyze basic radical is to analyze first group as a 6th group. For the analysis of 6th group, we will use this reagent, that is NaOH solution. When in original solution, if we add small quantity of NaOH, and when this mixture is heated, then from the original solution, this NH4 basic radical, NH4 plus basic radical, if it is present, then it react with NaOH and form NH4 plus ion and OH minus ion in the solution. These ions combine give NH4OH, that is ammonium hydroxide. This NH4OH further dissociate into NH3 gas and H2O. When a glass rod dipped in HCl solution is held on the test tube containing NH3 and H2O, then this NH3 forms NH4Cl fumes, and we know NH4Cl is a sublimating substance. It undergoes sublimation, so white dark colored fumes of ammonium chloride are formed that indicates presence of NH3, and this detects the presence of NH4 plus radical in the given original solution of mixture. Similarly, other test we can perform for the presence of NH4 plus radical is, if we hold moist turmeric paper on these fumes of NH3 gas, then this moist turmeric paper turns reddish brown. That also indicates the presence of NH4 plus radical in the original solution of given mixture. In this way, analysis of group 6 is carried out in our syllabus. In the group 6, only NH4 plus radical will be given. Actually, this group 6 contains K plus radical also, but in 12th standard syllabus, K plus, that is a potassium radical, is not given, and therefore group 6 contains NH4 plus radical, and it is detected using NaOH test. Then analysis of group 1. We will study analysis of all groups. So first we had studied analysis of group 6. Now we will study analysis of group 1. So group 1 consists of Ag plus, that is silver basic radical, then Pb2 plus, that is a lead radical, basic radical, then Hg2 2 plus, this can be written as Hg plus, that is called as a mercurous So these basic radicals present in the group 1. So how they are detected? So, or how they are analyzed? So if we add in the original solution of mixture, if Ki is added, potassium iodide is added, then if Ag plus basic radical is present in the original solution, then it forms AgI precipitate and it is having light yellow color, and this indicates the Ag plus ion is present in the original solution of mixture. Similarly, if this Ag plus, if it is not present, then this type of precipitate will not be formed. If in the original solution of this basic radical mixture Pb2 plus ions are present, they are again from the group 1, and if we had added Ki solution, potassium iodide solution, then if Pb2 plus radical is present, then it is converted into Pbi2 precipitate and it is having dark yellow color. So that indicates the Pb2 plus ion present in the given mixture. Then the third radical present in group 1 is Ag22 plus, or can be written as a Ag plus. It is called as a mercurous radical. If it reacts with Ki, then it forms Ag2I2 and it is a green colored precipitate. So from the color of the precipitate, we can identify the radicals present in the group 1 by using Ki, that is a potassium iodide solution or the reagent. Similarly, we can identify presence of Ag plus radical and Pb2 plus radical by using one more reagent called as a potassium chromate, that is K2CrO4, potassium chromate. When in the original solution this potassium chromate is added, then silver forms silver chromate with red colored precipitate, and if Pb2 plus is present, then it forms PbCrO4, that is a lead chromate and which is yellow precipitate. So from the color of the precipitate formed with this potassium chromate, we can easily identify in the given mixture either silver radical or lead radical if it is present. If both are absent, then remaining radical is Hg2 plus, Hg22 plus, that is a mercurous radical. So in this way, group 6 and group 1 radical can be analyzed. Now we will study analysis of group 2. Group 2 in the basic radical analysis consists of Pb2 plus, Cu2 plus, Bi3 plus, Hg2 plus, Sn4 plus, As3 plus, Cd2 plus, Sn3 plus and Sn2 plus basic radicals. Now how they are analyzed, that is which radical present in the group 2 that can be analyzed by using these different reagents. So for the group 2 analysis, we will perform the test like this. First we will take original solution in the test tube, then we will add dilute HCl, and then we will add H2S gas or H2S water. Then if there is a formation of black precipitate, that indicates the presence of either Pb2 plus, Cu2 plus, Bi3 plus or Hg2 plus radicals. These radicals forms black precipitate. Then if instead of black precipitate there is a formation of yellow precipitate by addition of original solution, dilute HCl and H2S, if we get yellow PPT, then that indicates presence of SN4 plus, AS3 plus, CD2 plus radicals. Then third set of radicals that present in the group 2 by addition of dilute HCl and H2S in the original solution, if we get orange colored precipitate, that indicates the presence of SN3 plus, and if brown colored precipitate is formed, then it indicates SN2 plus radical. So in this way, these different groups of radicals can be identified on the basis of color of precipitate formed in the group 2 reagent addition. Now, we will separate this group of radicals into individual radical. For example, in the original solution of this mixture, if we add potassium iodide, that is a Ki solution, then if there is a formation of yellow colored precipitate, so this yellow colored precipitate formation indicates formation of PbI2. This compound is formed and that indicates the given mixture contains Pb2 plus radical. So if yellow colored precipitate is not formed, instead of that, if white colored precipitate is formed, then the given mixture contains Cu2I2. This compound is formed, it is a white colored and it indicates the presence of Cu2 plus radical in the given mixture. So if yellow colored precipitate is not formed, white colored precipitate is not formed, but a black colored precipitate is formed, then it indicates the presence of Bi3 plus radical due to formation of bismuth iodide formation, that is BiI3, black colored precipitate. If with Ki solution there is a formation of red colored precipitate, then it indicates the formation of HgI2. It is a red colored and it indicates the presence of Hg2 plus basic radical. So in this way, Pb2 plus, Cu2 plus, Bi3 plus and Hg2 plus radicals can be detected by using reagent potassium iodide, that is a Ki. Similarly, in the next group of basic radicals, that is SN4 plus, AS3 plus and CD2 plus, these radicals are given here. This can be detected by adding H2S solution. So in the original test of group 2 radical, if we are adding original solution plus dilute HCl plus H2S. In the same test, if we get yellow colored precipitate, then that indicates that is excess H2S is added, then SN4 plus forms SNS2, that is stannous sulfide, and it is yellow colored stannic sulfide. It is a yellow colored precipitate. In that, if we add HCl, then it forms SnCl2. It is a colorless solution. In the same SNS2, this precipitate, if we add HCl, then it forms SnCl4 solution. In that again, Fe, that is iron metal is added, iron filings are added. Then we get formation of FeCl2 and SnCl2, and it gives the greenish yellow solution. That indicates the given mixture contains SN4 plus radical. If AS3 plus, that is arsenic radical, is present, then it forms arsenic sulfide having formula AS2S3. when dilute nitric acid is added, then it forms arsenic acid. In the arsenic acid, if we add ammonium molybdate, then it forms ammonium arsenate, and which is a yellow colored precipitate. So yellow colored precipitate formation, it indicates the presence of arsenic basic radical. Then the next radical in this group is CD2+, that is a cadmium dipositive ion. With H2S, it forms cadmium sulfide. This cadmium sulfide, in which it is converted into cadmium cyanide, and this cadmium cyanide is white colored precipitate. So this indicates the presence of cadmium in the given mixture. The last part of this group 2 analysis is SN2 plus and Sb3 plus ions if present in the original solution. So in the group 2, we know very well that is dilute HCl and H2S are added. Here, if the formation of orange colored precipitate, that indicates Sb3 plus radical that forms Sb2S3, that is antimony sulfide. This indicates the orange colored precipitate, and which means the presence of Sb3 plus radical in the given mixture. Similarly, Sn2 plus is a stannous radical. If it is present, and then it forms SNS, that is a stannous sulfide, which is a brown colored precipitate. In this way, in the group 2, if these different radicals are present, like Pb2 plus, Cu2 plus, Bi3 plus, Hg2 plus, or Sn4 plus, As3 plus, Cd2 plus, Sn2 plus, or Sb3 plus can be detected by using different reagents and different colored precipitate formation. Now, one more hint for the basic radical analysis is, we know for the group 2 radical analysis we are adding original solution, then dilute HCl and H2S. If this dilute HCl is not added in proportion, that is a less quantity, or if it is not added, then there are chances to form this zinc sulfide, this manganese sulfide, nickel sulfide, and cobalt sulfide precipitate formation. Actually, these radicals are present in the higher group, that is group 3b, but they are detected here only because the less quantity of dilute HCl is added. So add proper quantity of original solution with dilute HCl and H2S, then and then we get this group 2 radicals present. Otherwise, we will get the presence of this zinc radical, manganese radical, nickel radical, cobalt radical, which is present in the group 3b, but they are detected here because of this less quantity of dilute HCl addition. Now we will study analysis of group 3a. The test for group 3a radicals is original solution plus NH4Cl plus NH4OH. This NH4OH solution is added till the total solution becomes alkaline. This alkaline solution can be tested by using red litmus paper. That is, in the test tube, if you take small quantity of original solution, then add NH4Cl small quantity, then add small piece of red litmus paper, and then add ammonium hydroxide till this red litmus paper becomes blue, and that indicates alkaline solution. So when this alkaline solution is formed, then if there is a formation of white gelatinous precipitate, that indicates the given original solution of mixture contains Al3 plus radical. If in the alkaline solution there is a formation of reddish brown precipitate, and this precipitate is of FeOH thrice, and it indicates the presence of Fe3 plus ions in the original solution of given mixture. And if in the alkaline solution there is a formation of green precipitate, that indicates the precipitate of chromium hydroxide having formula CrOH 3 times. So this is green colored precipitate that indicates the presence of Cr3 plus radical. So in the group 3A, Al3 plus, Fe3 plus, Cr3 plus, these radicals are present and they can be detected by using reagent NH4Cl and NH4OH. So that is about the analysis of group 3A radicals. Very simple analysis. On the basis of color of precipitate of hydroxide form, we can easily identify presence of Al3 plus, Fe3 plus and Cr3 plus radicals. Now group 3B, analysis of group 3B. The test we are using for analysis of group 3B is, we had already prepared alkaline solution. So this is alkaline solution prepared in group 3A, but there is no precipitate, and the same alkaline solution we can use for group 3B. So in the alkaline solution, if we add hydrogen sulfide gas or hydrogen sulfide water, that is H2S water, then the group 3B consists of Zn2 plus, Mn2 plus, CO2 plus and Ni2 plus radicals. These radicals can be detected by using hydrogen sulfide in alkaline solution. If Zn2 plus ion is present in the solution, then it forms zinc sulfide precipitate, which is colorless. So colorless precipitate formation indicates the zinc ions are present in the given solution, that is the zinc 2 plus basic radical is present. If after addition of H2S, if we get buff colored, that is a pink colored precipitate, so this precipitate is due to manganese sulfide and it indicates the presence of Mn2 plus ions in the original solution of mixture. So if there is a no colorless precipitate, no buff precipitate, but there is a formation of black precipitate, here the black colored precipitate is formed due to this cobalt sulfide or nickel sulfide. Both sulfides are black colored, that indicates the presence of cobalt or nickel 2 plus ion dipositive ions as a basic radical. They can be separated, they can be analyzed further by using dilute HCl and potassium cyanide solution. So if you take this black colored precipitate of cobalt sulfide or nickel sulfide and dilute HCl is added, then if cobalt is present, it forms cobalt chloride, or nickel is present, it forms nickel chloride. In this chloride solution, if we add potassium cyanide, then cobalt forms cobalt cyanide, nickel forms nickel cyanide, but this cyanide precipitates, they have different color. If this cyanide precipitate is reddish brown colored precipitate, that indicates the presence of cobalt ion in the given mixture, and if yellow colored precipitate is formed as a cyanide, then nickel 2 plus ion is present in the given mixture. In this way, Group 3 consists of Zn2 plus, Mn2 plus, CO2 plus or Ni2 plus radicals can be analyzed, can be identified easily.
The analysis of group and contains the radical calcium, strontium and barium. Is it? Now, see, first of all, add alkaline solution, that is the mixture of ammonium chloride and ammonium hydroxide, and then add ammonium carbonate. Okay. Now, if calcium is present, then it gives the white precipitate of calcium carbonate, and to the white precipitate of calcium carbonate, if we add acetic acid, then it gives the corresponding acetate, that is calcium acetate. And if strontium radical is present, then after the addition of this, there is the formation of white precipitate of strontium carbonate takes place, and to this strontium carbonate, if we add acetic acid, then the formation of corresponding acetate takes place as usual. Then if group 5 is having the radical barium Ba2 plus, then it produces barium carbonate white precipitate, and to this white precipitate of barium carbonate, if we add acetic acid, then formation of the corresponding acetate, that is barium acetate formation takes place. Now these three corresponding acetates, if we add the three reagents one by one, then let us see what happens. Now if we take acetate of calcium, that is calcium acetate, to the precipitate of calcium acetate, if we add, that is ammonium oxalate, then formation of calcium oxide white precipitate takes place. And if the acetate is of strontium, that is strontium acetate, then if we add ammonium sulfate, then the formation of corresponding sulfate, strontium sulfate white precipitate takes place. Then if it is the acetate of barium, that is barium acetate, if we add, that is potassium chromate, then formation of yellow precipitate of barium chromate takes place. Is it? Yes. Now let us see the analysis of group 5. That is, to this here we are adding alkaline solution plus that is sodium hydrogen phosphate. Then if magnesium is present, then formation of precipitate of magnesium ammonium phosphate takes place. So this is the analysis of group 5 and group 6.
Good morning, students. Today in the chemistry laboratory we will study analysis of basic radicals. For today's experiment, this basic radical mixture, that is a mixture of two salts, is given. This is a binary mixture of salts, two salts containing two basic radicals. So take this small quantity of given mixture on rough paper with the help of small spoon. Then we will study step by step analysis of this basic radical mixture. So the first step in the analysis of this basic radical is preliminary test. So in the preliminary test we will observe first observation, that is color. So color of this mixture is a white or colorless. So this indicates the observation due to this is the inference are it is a colored radicals are absent, means colorless radicals are present in the given mixture. The second preliminary test that we will observe here is a nature of this given mixture. We had already studied that the nature of given mixture is either crystalline or amorphous or hygroscopic. So here the given mixture is crystalline. We can easily observe the crystals of this salt given in the mixture, and therefore nature of given mixture is a crystalline. The second step in the analysis of basic radical is to study dry test for basic radicals. For the dry test, we will take this one dry test tube. If it is not dry, then we will make this dry using burner. So this is now dry test tube. Now we will take small quantity of this given mixture in the dry test tube. So put this small quantity of mixture in the test tube. Then we will heat this with the help of burner. So during this heating, we will observe different observations. So we can hold this test tube with the help of this test tube holder. So if we heat this mixture slowly using this burner, then we will observe different observations. For example, here the colorless gas is given out, then this water vapor condenses on the cooler part of the test tube, then there is a small, so observation, first observation, here observation is water vapor condenses, so small water vapors, they are condensed on the cooler part of the test tube. The second observation is the residue obtained, which is white in color. So during hot condition, it is white. We will observe after some time it becomes again white. So change in the color of residue is before heating and after heating it is white in color. That indicates the presence of Al3 plus radical in the given mixture. So this is one of the tests in the dry test step, that is action of heat. Then next test we will perform for the basic radical analysis is action of NaOH. So we will take again one clean test tube. We will take small quantity of given mixture in the test tube. Then we will add small quantity of NaOH, that is sodium hydroxide solution. So we will add here small quantity of sodium hydroxide solution. Then we will heat this on the flame of this burner. During this heating, we will check turmeric paper. So in the action of NaOH, this is next dry test. So I will take small quantity of given mixture in the test tube. Then I will add small quantity of dilute NaOH. So small quantity of dilute NaOH is added in the given mixture, and if it is heated, then during heating I will hold this. This is turmeric paper. I will make this turmeric paper moist. This is turmeric paper. I will make this turmeric paper moist. Then I will hold this turmeric paper on the mouth of this test tube. Then, due to these vapors of ammonia gas form in the mixture, this color of turmeric paper becomes reddish brown. Color of turmeric paper becomes reddish brown. So this indicates NH4 plus radical is present in the given mixture. So this is approximate conclusion due to the dry test. Then the next test that we will perform for basic radical analysis is preparation of solution. Now I will take one clean test tube. Then I will prepare this mixture of this mixture and distilled water. So I will add distilled water. So this is distilled water. So I had added small quantity of distilled water in the given mixture. So small quantity of given mixture contains distilled water, and this solution is original solution. So this is original solution prepared for the given mixture. For the further test, we will use this original solution. So original solution is a solution of given mixture and distilled water. So after completion of dry test, we had studied action of heat and action of NaOH in the dry test step. Then third step we had already studied, that is a preparation of solution. We had prepared original solution of this salt, and we will use this original solution for the further test. So first test in the detection of group is, we know basic radical consists of group 1, 2, 3a, 3b, 4th, 5th and 6th group. So first we will test for the presence of 6th group. So test is again action of NaOH. So for this test I will take small quantity of salt, small quantity of mixture of these salts in the given mixture. Then I will add small quantity of NaOH in this, small quantity of NaOH. Then I will heat this mixture and I will test this turmeric paper. Before this I will make this turmeric paper moist. Now this is moist turmeric paper. I will heat this test tube and at the same time I will hold this moist turmeric paper on the mouth of this test tube. See that the color change of this turmeric paper. So this turmeric paper becomes reddish brown, and that indicates the presence of NH4 plus radical. See the color change during holding this paper. Turmeric paper becomes reddish brown. This indicates the presence of NH4 plus radical. We can also test this NH4 plus radical by taking the smell. So smell of ammonia gas, so that can be easily identified. One more test for testing this presence of NH3 gas is by dipping this glass rod. I will dip this glass rod in HCl solution and I will hold this glass rod on the mouth of the test tube. I will heat slightly, so you can see easily formation of ammonium chloride vapors. So ammonium chloride substance is formed. It is a colorless gas. So that also indicates the presence of NH3 gas or NH4 plus radical present in the given mixture. Now we will perform the confirmatory test for NH4 plus. For the confirmatory test, we will use Nessler's reagent. So this is Nessler's reagent. It is already prepared in the laboratory. So I will take small quantity of this original solution in the test tube, small quantity of original solution in the test tube. Then I will add small quantity of this Nessler's reagent. So Nessler's reagent is prepared by adding 1 drop of HgCl2. In that Ki solution is added, then we will get scarlet red colored precipitate, and this precipitate get dissolves by adding equal amount of NaOH. We will get the Nessler's reagent. If Nessler's reagent is added in original solution, then see that there is a formation of brown precipitate. So this reddish brown precipitate formation after addition of this Nessler's reagent, it indicates the NH4 plus ion is conformed. So this is about the first radical, that is the presence of NH4 plus radical in the given mixture. Now we will study next step in the analysis is detection of group. So the first group test is, this is original solution. I will add small quantity of dilute HCl, hydrochloric acid in this. Then there is a no formation of precipitate, simply solution is there. So this indicates the absence of group 1. Now we will go for the group 2 test. So this is original solution plus dilute HCl. I will add small quantity of H2S water in this. So with the help of this dropper I will add H2S water. So this is OS plus dilute HCl. Then I will add H2S water is added small quantity. Then there is a no precipitate formation. So this indicates the absence of group 2 in the given mixture. Now we will go for the group 3 radicals. In the group 3 radicals, group 3A, the test is, I will take this now original solution. So this is the original solution. In that I will add small quantity of this ammonium chloride, that is NH4Cl. So small quantity of NH4Cl is added. Then I will add one piece of red litmus paper in the test tube. So you can easily see this red litmus paper piece in the solution. Then I will add slowly this ammonium hydroxide, that is NH4OH, till this color of red litmus becomes blue. That solution is called as a alkaline solution. So I will add this NH4Cl solution, NH4OH, till this color of red litmus paper becomes blue. Then that solution is called as a alkaline solution. I will mix it well. So the color of this red litmus, it becomes blue. So after mixing, this color becomes blue. That indicates the alkaline solution. So the blue color of this litmus paper, that can be seen easily. See this color of red litmus paper which becomes blue. So this indicates the alkaline solution. So what I had added here, original solution plus NH4Cl plus NH4OH till alkaline, means red litmus paper becomes blue. So in this way I had prepared alkaline solution. Now the next test for the presence of group 3B is, I will take small quantity of this alkaline solution for group 3B test. So this is alkaline solution, small quantity. I will take this H2S water in this. So reagent for the group 3B are alkaline solution plus H2S water. So small quantity of H2S water is added here. So there is a no formation of precipitate. Again solution remains as it is, and that indicates the absence of group 3B radicals. We will test for the presence of group 4 radical. So this is again alkaline solution. I will add the small quantity of this ammonium hydroxide in this solution. So after addition of ammonium hydroxide in the small quantity, so this precipitate becomes white. So this indicates the presence of पुढे नाही जायचं आपल्याला. So this is original solution. I will take small quantity of NH4Cl small quantity. Then I will put one red litmus paper piece in this solution. So red litmus paper piece is added. Then I will add small quantity of ammonium hydroxide drop by drop. Then it will gives the gelatinous white precipitate formation. So this indicates the presence of group 3A in the given mixture. So we had detected presence of group 3A and group 6 in the given mixture. Now we will do analysis part of group 3A.
The precipitate of the color for third group A is white gelatinous precipitate. So Al3 plus is present. Okay. So after Al3 plus which is present, let us see the conformity test for Al3 plus. The first conformity test for Al3 plus is original solution plus NaOH, which gives white precipitate and which is soluble in excess. Okay, let us say the conformity test, this is OS. Let us add little amount of NaOH, okay, which gives the white precipitate, and if we add the excess NaOH, then it becomes soluble. So the formation of colorless solution takes place, which is soluble in excess of NaOH, the precipitate obtained in this reaction or test. Now the second CT is, there are only two CTs we are going to take. The first CT we have seen, and the second conformity test is original solution plus sodium hydrogen phosphate. Okay. Now let us say the second conformity test, this is original solution. Okay. Now let us take little amount of sodium hypophosphate and sodium hydrogen phosphate. See here, I will take a little amount. So again it gives a white precipitate. Okay. So this white precipitate indicates the presence of Al3 plus. Okay. So here two conformity tests we have seen. The first is original solution plus NaOH, which gives a white precipitate, and more excess addition of NaOH, the precipitate disappears and the solution becomes transparent. That is called as soluble in excess NaOH. Now the second CT we have seen, that is original plus sodium hypophosphite. We get the white precipitate, which confirms secondly, that is Al3 plus is confirmed. Now let us see the result. First radical, in the beginning we have seen the test for a sixth group, that is ammonia was present in that group. So the first radical basic, which is NH4 plus ammonia, and the second radical, it is confirmed, that is Al3 plus. So our result, finally we have to rate the result, that is result or conclusion. The result is like this. The given mixture contains two basic radicals, A, that is NH4 plus, and B, that is Al3 plus. This is the result which has separate weightage in the practical work. Okay, thank you.